All right, guys, we are looking at factoring quadratics with a equals 1. Our mission today, I can factor quadratic expressions in standard form with an a term that equals 1. So remember that our standard form of a quadratic equation is y equals ax squared plus bx plus c, okay? So when we're talking about quadratics that have an a equals 1, in other words, there is a 1 right here, so you don't really have a coefficient here. Remember that 1, we could write it or not write it. It doesn't really change the problem whatsoever. So we're talking about factoring expressions that have that standard form with an a that equals 1. So probably the best way to do this is just jump in. We've got about 4 examples we're going to take a look at today. So hopefully this will be helpful to you. So let's look at number 1. We've got x squared plus 11x plus 24, okay? So again, you notice right here I have a 1. Really, that's not written there, and it's because it doesn't really make a difference. So we doesn't really need it either. But as soon as you see that situation, there's a particular way that you go about factoring this expression. Remember, when we say we're trying to factor, we're trying to get down to 2 binomial terms, okay? So in other words, what we're trying to get to as far as an answer is something that looks like this, right? And we're going to have values in here that if I fold them back out, they would make this here. So it's basically the reverse of what we started with. We started by multiplying binomials. Now we're trying to break those binomials back apart, okay? And we're looking at what we would have really had we multiplied the binomials, and we're trying to work our way backwards. All right? So that's why we spent so much time in trying to make sure that you understood how that you even come up with things like this. It was by multiplying 2 binomials, right? So now we're trying to break that down. So what you need to think about is how in the world am I gonna come up with this, okay? And so there's a couple of things we have to think about. First of all, let's think about how in the world do I get x squared, okay? How do I get the term x squared? What's that really made up of? Well, what I want you to think about is if I take x to the first power and I multiply that times x to the first power, remember when I multiply exponents, I actually add them. So in this case, if I take x to the first times x to the first, I'm going to end up with x squared, which is kind of what I need right here. So in order to get x squared, I'm going to have to take x times x somehow, some way. Well, let's think about this for just a second. If I make my first term x here and my first term here x, then when I FOIL this out, right, I'm going to get x times x, which is x squared. I'm going to get this term right here, okay? Now what I need to figure out is I just need to figure out what else goes in here, okay? I've got this part down, but how in the world do I get these other parts to this equation? Well, what I'm going to tell you is that you always need to focus on this c term. When you have a quadratic that has an a that equals 1, you need to focus on this c term right here and think about this c term. Now think about what we're doing. We're factoring, okay? So you need to think about the factors of that c term. I don't know what that is that just come up, but that's okay. So our c term here is 24, okay? So what I want us to do right now is I want us to think about the factors of 24. All right, now you've done this before. So we think about the factors of 24. What numbers go into 24? And it's always easiest just to start with 1 because 1 will go into any number, right? 1 and 24. If you multiply those together, you will get 24. Then you move to your next number down the line. So 2 times what will give me 24? Well, 2 times 12 will give me 24, right? And then let's move to 3. 3 times 8 will give me 24. And 4 times 6 will also give me 24. Now, when you get really close like this, then you know that you're almost there. So you could try 5. 5 wouldn't work. And now you notice I'm going right back to 6 again. So I'm starting to kind of back up the tree again, okay? Now, here's what you need to think about these factors that we have here. We've looked at all the factors of 24. Now we're going to focus on our b term right here because now notice I have an addition symbol right here. So now I'm looking for 2 numbers in this list that will add up to a positive 11. okay? So look at this list of numbers. What two numbers adds up to a positive 11? Well, it's right here, right? 3 plus 8 adds up to 11. And so guess what? Those are our two terms that go in right here. So I'm going to put a positive 3 and a positive 8. And that's it. We found the answer. Now, again, how do we determine whether that is really the answer or not? Well, let's do 4. We already know that x times x is x squared. We know that x times positive 8 is positive 8x. 3 times x is 3x, and 3 times 8 is 24, okay? Notice the only terms that I need to combine are right here, so I end up with x squared plus 11x plus 24, which was my original answer right here. So my answer for this particular one would be this. These two binomial factors are the factors of this particular quadratic that we're looking at, okay? All right, let me go ahead and just erase this part, hopefully. Okay, and let's go ahead and do number 2 right here. So we've got number 2, that is x squared minus 14x plus 45. Okay, so first of all, I'm going to check. I want to see if I have any greatest common factors. I don't. I've got a 14 and a 45. That doesn't really help me at all. I do have a 1 right here, right? So if I have that 1 right there, where's the first place I'm going to look? You guessed it, C. I'm going to look at my C term, which in this case is 45. And I want to look at the factors of 45. So we're going to go ahead and just do that over here on the side, 1 and 45. What else goes into 45? Well, our hint really is this 5 right over on the side. So the only other numbers that go into 45 are 5 and 9. Now notice again, I have an addition symbol right here. This addition symbol tells me what operation I need to do, okay? Now, I want to say this as well. What kind of answers am I trying to come up with? I'm trying to come up with two binomials, right? So I'm going to go ahead and just make my parentheses. And how do I get x squared? What do I need to multiply together to get x squared? X times x, right? Now I'm just looking for what goes in here. Well, again, this is addition. So I need to find two numbers that add up to, yes, you guessed it. Now I need to start focusing on my b term. Well, what is my b term? My b term is negative 14x. Are there two numbers over here that add up to negative 14? Well, 5 and 9 is 14, but not negative 14. How in the world could I come up with negative 14? Well, think about this. What if I made this negative and multiplied them together? I'm still going to get a positive 45, but if I add them together, then I am in fact going to get that negative 14x. So ladies and gentlemen, right here would be my factors that would go in there. So I wanted to show you that one because these can be negative as well. They don't necessarily have to be positive. And again, we could FOIL this out. We'll do that kind of quickly, just so you see it. X squared, x times negative 9 would be negative 9x. Negative 5 times x would be negative 5x. Negative 5 times negative 9 would be positive 45. And voila, there you have it again, where we come right back to the original answer that we originally started with. Okay? All right, so now let's move on to two more problems. We'll try to get through these kind of quickly. At least this third one. The fourth one will take a little bit more time on as well. Okay, so let's see here. It's the best way to do this. Let's just let's get this guy out of the way, and let's just clear that canvas. All right. So here we go with number 3. And number 3 is x squared plus 2x minus 35. So now we notice, again, ax squared plus bx plus c is our standard form. We do, in fact, have a 1 in this spot here. So we know that our focus should be on C, which is a negative 35, okay? We know we're going to be trying to find two binomials. We know that we're trying to find x squared, so that would be x times x. You kind of see a pattern that starts repeating. Now I need to find the factors of 35. So 35 would be 1 and 35, and let's see, 5 and 7, right? 5 times 7 is 35. That's the only factors that we have of 35. But here's what I want you to notice with this problem. This is why I wanted to do this problem, because now I have a subtraction symbol here. I no longer have an addition symbol. So what I want you to realize is if I've got a subtraction symbol here, a negative is really a subtraction symbol, then that means I need to subtract two terms to get a positive 2. Okay, so this really tells me what operation I need to do. Okay, again, my focus is still trying to come up with this B term, but this right here is telling me what kind of operation I need to do. So what two terms over here could I subtract and get a positive 2? Well, 5 and 7, but if it's going to be a positive 2, which one's going to be positive and which one's going to be negative? Well, the higher number would have to be positive, right? So 7 would have to be positive, which means this 5 has to be negative, okay? So pay attention to that. Anytime you've got that subtraction symbol, I've got to do subtraction of the two numbers to try to get a positive 2. So that means my two terms over here are negative 5 and positive 7. And there's our answer. Okay, we're done. So again, we folded enough that you know now that it's going to work out. But that's one way that you can check to make sure that your answers are right. You can go ahead and fold that out and see if it works. Now let's look at number 4. And you're going to tell me that I lied to you when you see this problem. But after we look at it, you're going to see why. 2x squared minus 2x minus 24, okay? And right off the bat, you're thinking, wait a minute, Mr. Hamilton, I thought that we were doing problems that had a 1 in this A spot right here, and this is definitely not a 1, okay? What I want you to think about is the fact that you should always be looking for greatest common factors, okay? Greatest common factors. Look at your coefficients here. You've got a 2, and a 24. Is there a greatest common factor that I could pull out of those numbers? And the answer is yes. There is a greatest common factor, and that greatest common factor is, in fact, 2. So watch what happens if I pull a 2 out to the front. Now what I have left is 2 times x squared would give me 2x squared. 2 times a negative x would give me negative 2x. And 2 times a negative 12, 2 times negative 12 would give me negative 24. So this here is equivalent to that. The only difference is now I factored out a 2, and now I have a quadratic inside of these parentheses that has a factor of 1 right here for the A term, okay? So sometimes you're going to need to pull out a greatest common factor before you ever start so that you can then factor this out, okay? So what we're going to do is we're just going to kind of leave this 2 kind of hanging out here, and we're just worried about this part, okay? So again, let's do what we've been doing all along. We're going to, as long as I've got a 1 there, I'm going to be looking to this as my factors. So the factors of 12 would be 1 and 12, 2 and 6. And again, these are just numbers that go into 12 when you multiply them. 3 times 4, okay? All of those numbers are factors of 12. Now, what is our sign here? Our sign is a negative. What does that tell us? That we need to subtract two numbers, and those two numbers need to come up with this negative 1x, okay? So let's go ahead and make our two binomials. Again, I'm just leaving this 2 hanging out here at the front. It's okay. And I know that x times x is going to make x squared. What two numbers over here can I subtract and come up with a negative 1? Well, 6 minus 2 is 4. That doesn't work. 12 minus 1 is 11. That definitely doesn't work either. So the only two numbers that I can subtract and come up with a negative 1 are these two numbers right here. Now the question becomes, in order for that to be a negative 1, which one of these two numbers needs to be negative? Pause, think. It would have to be this one, right? The -4. -4 plus 3 equals -1. So, and here's the other thing. It doesn't matter whether the 3 goes here, the 3 goes there, as long as you've got the signs right on them. So in other words, I can make this a +3 and I can make this a -4. It doesn't matter about the order because remember, a multiplication is commutative. So when you multiply it out, it's still going to end up being the same thing, okay? So this would in fact be our answer for that particular one. Again, pay attention because that is on your practice, okay? So not very many problems on this practice, but I think it's going to be very helpful for you to do this. Listen, factoring is not going to go away. When we get into rational expressions, we're going to have to factor, which is the next chapter. When we get into the next chapter after that, we're still going to need to factor. When you get to college algebra, you are definitely going to have to factor a lot, okay? And this is not something you can just throw in the calculator. So that's why we're really spending time with this to make sure you get it, because you're going to have to know how to do this, not only this year, but next year as well, okay? All right, we'll see you tomorrow. And if you need any help between now and then, and just reach out to us. Thanks.